In the previous video, I discussed about Descartes' rule of sign. But Descartes' rule of sign doesn't give exact number of real roots of an equation. So in this video, we are going to discuss about Sturm's theorem, which gives us the exact number of real roots of a polynomial equation with real coefficients. So let's begin. The statement of Sturm's theorem is when the roots are unequal and fx be a polynomial with real coefficients, and we are going to calculate the roots between a and b, where a is less than b, the number of real roots of the equation f of x, which are lying between a and b, is equal to the difference between the number of changes of signs in the sequence of Sturm's function when x equals to a over the number of changes of the sign in the sequence when x equals to b. And for a multiple root or equal roots, we have to count the multiple root only once, and then the theorem is same as before. Let's learn how to calculate Sturm's function. Suppose f of x equals to 0 be a given equation. So the first Sturm's function is f of x. Now f on x is nothing but the first derivative of f of x, and f on x is the second Sturm's function. And let's do the operation of finding HCF of f and f1 with slight modification. The modification is the sign of each remainder is to be changed before it used as the next divisor, and the sign of the last remainder is also to be changed. That means if we divide f by f1, we will get some quotient here, let's say q1, and some remainder here, let's say r1. Now when we use r1 as the next divisor, that means we have f2, and f2 is nothing but r1 with the sign change. Then we divide f1 by f2, because f2 is the next divisor, and we will get some quotient, let's say q2, and we will get r2. So our f3, the next Sturm function, will be negative r2. Okay. For better understanding, let's do an example. Consider x cube minus 3x plus 1 equals 0. Now we are going to find the number of real roots as well as the position of them. So first let f of x is x cube minus 3x plus 1, which is the first Sturm's function. Second f1 will be the derivative one. So derivative will be 3x square minus 3, and after removing the factor 3 we will get x square minus 1. So removing factor 3. So we have to divide f by f1, that is divide x cube minus 3x plus 1 by x square minus 1. So put x here, we will get x cube minus x, change their sign, okay, cancelled, negative 2x plus 1. So the next divisor is negative 2x minus 1, and we have to change their sign, that is our f2, the next Sturm's function, is 2x minus 1. So f2 is the next divisor, so 2x minus 1 we have to divide x square minus 1 by 2x minus 1. Now just we are finding HCF, so multiply by 2. We don't want the quotient, only we are interested in remainder, then multiply by 2. So 2x square negative 2. Now put x here, we will get 2x square negative x, or change sign, this will get cancel, x minus 2. Again multiply this by 2, we will get 2x minus 4. So plus 1 will get 2x negative 1. Change its sign, this will get cancelled, this is 3. So 3 is the last remainder and we have to change its sign as well. So f3 is nothing but 3. Therefore, the Sturm's functions are as follows. F of x, that is the given equation, x cube minus 3x plus 1. F1, we calculated F1 as x square minus 1, x square minus 1. F2 as 2x minus 1, and F3 is 3. So we calculated a Sturm's function. Now we need to apply the Sturm's theorem. So for that, let's write down f1 x, f2 x, and f3 x, and here changes of sign. Changes of sign. So when x equals 0, so the first f of x, put 0 here, we will get 1. That means positive. F1 will be negative, F2 will be negative, and F3 always positive. So number of changes of sign is 1, no change, 1, again 1. So total 2 changes. Okay. So now for positive 1, let's calculate for x equals 1. So for x equals 1, if we put x equals 1, we'll get 1. F of 1 will be 1, negative 3, positive 1. So we'll get negative 1. So this will be negative. For 1, this will be 0. This will be positive, and F3 is positive. So only 1 changes. That means the theorem says between 0 and 1 there is a root. 1 root. Okay. Let's calculate x equals 2. So at x equals 2, f of 2 will get 8, negative 6, positive 1, and this is positive. See, 3. So first one will be positive. F1, 2 square, 4 minus 1, 3, again positive. F2 is positive and F3 is always positive. So no changes, 0 changes. But the difference between 1 and 0 is 1, means there is an excess. So between 1 and 2, another root is there. Okay, what about at 3? So when x equals 3, f of 3 is 27 minus 6 plus 1, that is again positive. When f1 is positive, f2 positive, and f3 positive. Positive, 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 and positive. So no changes. So between 2 and 3 there is no root. So we got 2 positive roots, one between 0 and 1 and another between 1 and 2. Okay, let's go for negative. So let's calculate at negative 1. So if we put x equals to negative 1, the first one will be f of negative 1, that is negative 1 plus 3 plus 1, and this is again positive. Okay, positive. For f1 will be 0. f1 0, f2 will be negative and then positive. That means one change and then one change. Total two changes. See, between 0 and negative 1 there is no negative roots. So let's calculate at x equals negative 2. So for negative 2, f of negative 2 will get negative 8, positive 6, positive 1. So this is negative. So f is negative at x equals negative 2. Okay, what will be f1? f1 will be positive and f2 will be negative. See, f1 is 4 minus 1 and positive, and here minus 4 minus 1 negative, f2 is negative. So first f1 is positive, yeah, f1 is positive, f2 is negative, and then f3 is always positive. So one change, two changes, and three changes. So between negative 2 and negative 1 there is a root. Our given equation is a cubic, so it has three roots that may be real or complex. Now see, we got two positive roots and one negative roots. And more specifically, the positive roots lies between, one lies between 0 and 1 and another is 1 and 2, and the negative root lies between negative 2, negative 1. Another example. Let's say the given equation is x to the power 4 minus 6x cube plus 10x square minus 6x plus 1 equals 0. So f of x is nothing but this whole thing. So f1 x, what will be the f1 x? Let's calculate f dash x. That is the first order derivative of f of x. So 4x cube negative 18 x square plus 20x negative 6. Okay, so removing factor 2 will get 2x cube minus 9x square plus 10x minus 3. Okay, now divide f, that is x to the power 4 minus 6x cube plus 10x square minus 6x plus 1 by f1. So that is 2x cube minus 9x square plus 10x negative 3. So we are finding GCD with modification that the sign of the next divisor will be changed, and also the last remainder will be changed also. So just multiply by 2, we'll get 2x to the power 4 minus 12x cube plus 20x square minus 12x plus 2. Okay, put x here, we'll get x 2x to the power 4 minus 9x cube plus 10x square minus 3x. Change signs, negative, positive, negative, positive. Get cancelled. Negative 3x cube, positive 10x square, and then we'll get negative 9x plus 2. Okay, multiply by 2, we'll get negative 6x cube plus 20x square, negative 18x plus 4. Put here negative 3. So negative 6x cube, positive 18x square, negative 30x, positive 9. Positive, negative, cancelled. You get 2x square. What? Oh, sorry. This will be 27. So negative 7x square, positive 12x, negative 5. Okay, now correct. So we got F1, F2. So F2 will be with the sign change. The next divisor will be F2 and we have to change its sign. So 7x square, negative 12x, positive 5. Now divide F1 by F2. So what is our F1? F1 is 2x cube minus 9x square plus 10x. 2x cube minus 9x square plus 10x, negative 3. So multiply this by 7, we'll get 14x cube, negative 63x square plus 70x minus 21. So 2x, 14x cube minus 24x square plus 10x, negative, positive, negative get cancelled. Here we'll get 39, negative 39 x square plus 60x minus 21. Okay, multiply this by 7, we'll get negative 7 times 39 x square, 420x minus 7. So we have to put here my negative 39. So we'll get negative 7 times 39 x square, 468x, and then negative 195. That means positive, negative, positive cancelled. Here we'll get negative 48x, positive 48. So F1, F2, F3. So F3 will be x minus 1, removing factor 48. And now divide F2 by F3. So F2 is 7x square minus 12x plus 5. So 7x, So 7 x square minus 7x, negative positive get cancelled, negative 5 x plus 5, negative 5, so negative 5x, positive 5, positive negative get cancelled, and 0. That means f3 divides f2 without remainder, and this shows that the given equation has a multiple root. The given equation has a multiple root. And see, f3 is x minus 1, that is the last remainder. That means in the proceeding of finding HCF, x minus 1 is the common factor. So x equals to 1 is the multiple root. This is multiple root. So let's write down all the Sturm's function together. So here is the function f, f1, f2 and f3. So write x, f, f1, f2, f3 and changes of sign. Change of sign. So at 0, what we will get? F is positive, then f1 negative, f2 positive, f3 negative. So 1 change, 2 change and 3 changes. 3 changes. Now let's calculate at negative 1. At negative 1, this will be f of negative 1 will be positive 1, then positive 6, then positive 10, then positive 6 and positive 1, that is positive. So f is positive, f1 will be negative 2, negative 9, negative 10 and negative 3, all are negative, so it will be negative, and f2 will be 7 plus 12 plus 5, all are positive, so it will be positive, and f3 will be negative. So 3 changes. Now C1 is a double root, so let's calculate it half. So at half, f3 will be negative. So half minus 1, that is negative half. So negative f2 at half, this will be 7 by 4, and then negative 6. 7 by 4 is greater than 1, and here will be minus 1. So f2 will be positive, and at half f1 half, that will be 2 by 8 minus 9 by 4 plus 5 minus 3. So this 2 will be 2, and here if we calculate this thing, what we'll get? 8, 2, negative 18 and then positive 16. So will be 0. This will be 0, and at half f1 will be negative. So we have 1 change and then another 2 changes. So between 0 and half we have 1 root. So let's calculate at 2, because at 1 1 is the double root. Let's calculate at 2. So at 2, the change of sign will be similarly negative, negative, positive, positive. That means only 1 changes. So between half and 2, there is a root. At the changes of sign will be like this: negative, 0, positive, positive. That is 1 change. So no root between 2 and 3. And at 4, positive, 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 positive. So all are positive. So here is a difference 1. So between 3 and 4 we have a root. So the roots are lies between 0 and half. Between half and 2 there is a root, and that is double root, that is 1. And between 3 and 4 another root is there. And all the roots are positive for the given example. Thank you.